the reason that a bunch of this turns into this is because of a digital to analog converter. It uses the on and off logic of computers to approximate continuous voltage signals for things like sound. But if a computer's binary logic can only output 0 or 1, then how do we get the values in between? Well, that's where the DAC comes in. And one of the most common ways to build a DAC is the R2R ladder. But how does it turn binary into analog values? Well, let's drive it. Say we have a DAC with 4-bit precision. That means we can represent 2 to the 4 or 16 discrete voltage values, each incrementing by 0.26 volts every time you add a bit. We can see how we came to this conclusion by using Thevenin's theorem, which states that all linear circuits can be simplified into this equivalent circuit. If we feed in a binary value of 1 into the circuit, then the circuit simplifies into this. Using Thevenin's theorem, we can replace everything on the left side with an equivalent Thevenin voltage and equivalent Thevenin resistance. To get the Thevenin voltage, we simply have to take the voltage drop across this resistor. And to do that, we can use voltage division, which shows us that the Thevenin voltage is 3.3 volts divided by 2. To find the Thevenin resistance, we have to first deactivate the voltage source, which means shorting it. Since these resistors are in parallel, we can find the equivalent resistance by using this formula. Once we have our Thevenin equivalent circuit, we can just slap it back onto the rest of the circuit. And then the cycle just repeats. And it's here where you might find a pattern. Every time you find the Thevenin equivalent circuit, the Thevenin voltage always halves. And if we keep simplifying the circuit until we can't anymore, then we can see that for an input value of 1, we'll get an output voltage of 3.3 volts divided by 16. And using Thevenin's theorem, we can see that for inputs 2, 4, and 8, we get outputs of 3.3 volts divided by 8, 3.3 volts divided by 4, and 3.3 volts divided by 2 respectively. And using superposition principle, we can solve for the output of any input value that can be expressed with 4 bits. For example, if you want to know the output voltage if we had an input value of 13, then we would simply add 3.3 volts divided by 2 plus 3.3 volts divided by 4 plus 3.3 volts divided by 16. For more educational tech content, follow along.